right, our last talk for today, I mean we have 2 more days, so don't be too sad, is Chen from Michigan.
Thank you. Thanks to Dorothea and David for organizing the workshop. So this is joint work with Yinghua, who's sitting right there. And we're going to talk about a lab experiment that looks at information acquisition and provision in school choice. And the advantage of having the last talk of the day is a lot of the concepts are being explained by Katerina and other speakers. So in the school choice literature, students choose which schools to attend. And the centralized matching mechanism has been fairly popular in different parts of the world. And typically, you have lots of schools to rank. And in New York City, for example, there's a brochure that's about 700 pages long. And from that brochure, you're supposed to pick 12 schools to rank. So there's a lot of information to process. In college admissions as well, students need to choose which college or universities to attend. And again, there are typically hundreds of colleges and programs available. So the information problem here is that the relevant information, for instance, the quality of the school and whether it's a good match for you personally, might be unavailable or costly to acquire. So this is a quote from a parent in New Orleans who says that it was very hard and very time-consuming to find a school for her daughter. So this is someone, the daughter is attending kindergarten. So she said, I am educated and I have a bachelor's degree and I do have time to read articles online, research things, and she still finds it quite difficult to do the ranking. And in this classic school choice literature, we just assume that people know their preferences and that's a given. And we're basically looking at how do people find out about their preferences, and there are also a fair amount of field experiments and empirical evidence which show that providing more information could change student choices. So there's a field experiment by Hastings and Weinstein that looks at, I think, North Carolina school choice. Again, the default is a thick brochure with alphabetically ranked schools. So the authors actually distilled them to a 3-page summary of the feasible schools and ranked them by the school quality measured by standardized tests. And they find that that systematically changes parents' rankings of schools, and that the more academically demanding schools are in higher demand in their intervention. The other piece of information is looking at information on financial aid. So there's a paper by Hawksby and Turner, and the title actually says it all. And the title is, what do high-achieving and low-income students know about colleges? And the answer is not much. Lots of them, for instance, would apply for their public university in the state, thinking that the private universities are not financially obtainable, but not knowing that the financial aid actually is quite generous in a lot of private schools. And there are also a lot more examples. So in this paper, we're going to look at students' incentives to acquire information about their own preferences. So this is a departure from the school choice literature or the classic school choice literature. We assume that this is in a private value environment and also for others' preferences. So this is for strategic considerations. We're also going to look at how their incentives might vary under different school choice mechanisms. And we also measured the welfare effects of information provision by the education authorities. So in the end, I'm going to talk about several real-world examples of the education authorities supplying information. So we have a theoretical model. This used to be one paper. Now it's split into 2 papers. So in the theoretical paper, we characterize the optimal strategies for the students. And then I'm going to focus on the lab experiment, which provides empirical evidence. And also, because we use induced value methods, we could do counterfactual analysis of welfare policies. So there is an extensive literature on information acquisition, and in the mechanism design context, most of this literature is in the auction context, and there are a few papers on information acquisition in matching. And I'm going to, once I present our results, I'm going to come back and revisit some of these experiments. It turns out that the one finding that we see in our data, which is over-acquisition, is quite prevalent in previous example as well. And there's also a literature on advice giving in school choice, and that's in that setting, the information is exogenous. So like it or not, you're going to get advice. Whereas in our case, we measure the incentives to acquire information. So I'm going to quickly go through the theoretical analysis that provides the benchmark for our experiment design and focus primarily on the experiment results. So a typical school choice problem consists of a set of students and a set of schools. Each school has a quota. For simplicity, we say that the schools don't rank students ex ante, and so you use a random lottery ex post. There are varying information structures on preferences. So the previous literature assumes that the ordinal preference or the cardinal preference is known. And under this set of assumptions, the canonical school choice mechanisms include the Gale-Shapley deferred acceptance or the Boston immediate acceptance mechanism, which Katerina has introduced. And the strategy in the setting is that the students will submit a rank order list of schools. So I'm going to now just skip the slide. So we in our experiment, we compare these two mechanisms, the Boston immediate acceptance and the Gale-Shapley deferred acceptance. So the one part to remember about the immediate acceptance mechanism is that it's not strategy proof. For the DA, matching at every step is temporary until the algorithm terminates, so truth-telling is a dominant strategy. So information acquisition in our setting essentially put a stage game, before the school choice game. So now you have two stages. Before you submit the rank order list, there's common knowledge of the distribution of the school values, but you don't know the realization. So the costly information acquisition is a sequential acquisition process. So you first invest in acquiring ordinal preferences, alpha, which is bounded, and then you might invest in acquiring cardinal preferences. So one way to think about this, about ordinal and cardinal preference in this setting, is that cardinal preference is more in-depth information about a particular school. In the experiment, we'll actually collapse these two stages together. So this is, I know this is a little bit busy. This is the process, the technology for information acquisition on own values. So nature draws your cardinal preference is VI, which implies your ordinal preference. So at this point, everyone knows the distribution, and so player I decides whether to acquire information on ordinal preferences. If you decide not to, you enter the school choice game just knowing the distribution. And if you decide to acquire information, so alpha is how much you invest in information acquisition, you can think of sending your child to a school and spend a day, shadowing the students and so on. Or you can choose to read their webpage. So I chooses the amount to pay to acquire information, and with probability A of alpha, you learn the information, and with probability 1 minus alpha, you don't. Again, you would enter the school choice game, only knowing the distribution. After knowing ordinal preferences, you can decide whether to invest more to acquire the cardinal preferences. If you decide to invest, again, with certain probability, with probability B of beta, you know your VI, your cardinal preference. And if you decide not to invest, or you invest, but you didn't get the information, you enter the school choice game only knowing your ordinal preference. Yeah, David.
This is acquiring all of my ordinal information, or just on some comparisons of schools?
So in the example, in the experiment, we're just talking about one school. But this could be, the profile of, let's say, 12 schools.
And what is the role of the probability in your model? Because you could have written that all down, I think, without the probability piece.
Yeah. So you could. So the idea is you went. Let's say your child goes to a school and spent the day, made the investment, but still couldn't decide whether that was a good match or not.
Will it play a technical role as well? Would things not go through without the probabilities?
So Yinhua's going to answer that question.
Here's just a modeling choice to capture the intensity, how much you want to invest.
Okay, so I'm going to talk about the two characterizations, which is two propositions about the each mechanism. So we first look at the incentive to acquire information about own preferences. So under the bounded costs and the Inada conditions for the technology, we have that in any symmetric Bayesian-Nash equilibrium, students always have an incentive to learn their own ordinal preferences. And under DA, there's no incentive to learn their own cardinal preferences, whereas under IA, there is a distribution. There exists a distribution of preferences such that students have an incentive to learn their own cardinal preferences. And the third part is true for all strategy proof mechanisms that elicit ordinal information from students. And then yeah.
Is it true that you don't acquire information at all?
Pardon?
Can you explain the Inada condition?
Yeah, so the Inada condition, you mean, so for the technology, so it's if you invest nothing, you get nothing. The A is 0 and is concave. So the marginal return for investment at 0 approaches infinity, whereas it goes to 0 as it approaches, as it goes to infinity. But in this case, it's actually bounded. Alpha is bounded. So we're at the others preferences. So the incentive to acquire others preferences is so again, in the Bayesian framework, in an arbitrary symmetric Bayesian-Nash equilibrium, under DA, there's no incentive to learn those preferences because it's a dominant strategy it's strategy proof. And under IA, there exists a distribution of preferences such that some students have an incentive to learn others' preferences. So that's the benchmark that we use for the experiment design. So in the experiment, we have the simple setting of 3 students and 3 schools. Each school has 1 slot and ranks students with a lottery. So the payoff distribution is going to be, the A is a good school, so you get 100 points. If you get A and C is a bad school, you get 0. Whereas B, there's some uncertainty about B. So it's better than A with probability 1/5 and almost as bad as C with probability 4/5. So the uncertainty here is on the realization of the value of B. So ex ante, the expected payoff of B is 30. So submitting ABC is a dominant strategy. So the only source of inefficiency in this environment is if there is at least one student with high value for B, you assign B to someone with a low value. Okay. So in the experiment, we use a complete factorial design. So we vary the mechanisms and the information to acquire and the cost condition. So the mechanisms and the information to acquire are between subjects, whereas the free versus costly information acquisition is within subjects. So that's primarily designed to enable learning. So here is features of the experimental sessions. So each session has 12 subjects, so we use random rematching to avoid the repeated game effects. So for half of the sessions, they play basically 10 rounds of the school choice game with free information, followed by 10 rounds with costly information acquisition. So the piece of information you would need to rank the schools were free for 10 rounds, and then we say, well, now you have to pay for it. I'm going to talk about the details of how we implement it. And then we also reverse the order. So thinking about the order effect as, in the costly to free condition, in the first 10 rounds, you would need to learn a fair amount of things. You need to learn the mechanism as well as the information acquisition piece. Whereas in the free to costly, we separate these two processes. So the first 10 rounds, you only need to learn the mechanisms, whereas the last 10 rounds, you need to learn the information acquisition piece. Okay, so how do we elicit people's willingness to pay in the lab? Yeah.
So what was the difference between own value and others' value? Was B different across agents?
Yeah, so your value for school A and C is the same for everyone. But for B, it's a random draw for everyone, for every person, every round, right? So you can imagine that under Boston, it's useful to learn what others' valuation might be. So we use the Becker-DeGroot-Marshak mechanism, and so they can enter their willingness to pay for either their own value or others' values. And the server collects their willingness to pay and generate a random number between 0 and 15. If your willingness to pay is above the random number, then you find out the information and pay the random number. Otherwise, you don't find out the information and pays 0. And the instructions are adapted from a prior experiment. Basically, we write as Ben Habib et al. That, you should just tell your true willingness to pay. So that's how we elicit that information. The other piece is to elicit their beliefs. So we elicit their beliefs about others' information acquisition. And so belief elicitation is a fairly actually messy enterprise. So we use a scoring rule called the binarized scoring rule. And the basic idea of the scoring rule, so I have until, David, 5 o'clock, right? Yep. Yeah, okay. So basically, the binarized scoring rule says that if you're close enough, you will get a fixed price, otherwise you get nothing. Okay, so the idea is to basically bypass the curvature of the utility functions. You don't have to be an expected utility maximizer for this elicitation method to be incentive compatible. And so this is first analyzed by Hussein and Oku. All right. So one strength about this paper is the battery of measurements, which enables us to decompose people's willingness to pay. So at the end of the experiment, we elicit people's risk attitude using the Holt and Laurie measure. So that's about sort of a set of lotteries. And we also have a measure which we call curiosity. So basically, the Holt and Laurie measure says for each of the 10 lotteries, either choose this, you can tell us whether you want to choose the safe or the risky lottery. And we determine your risk preferences based on your switching point. And so usually the way it's implemented is that, at the end we say, okay, lottery 6 is chosen, randomly chosen, and your payoff is this. Instead, we say your payoff is this. How much are you willing to pay to find out which lottery is chosen? So that elicits people's, at that point, there's no utility from knowing which lottery is used. So we essentially measure people's willingness to pay for non-instrumental information. So we call this curiosity. It turns out that this is going to explain a fair amount of people's willingness to pay, okay, for information. So let me show the experiment data. So this is the combined data for people's willingness to pay for their own values in the immediate acceptance mechanism and the deferred acceptance mechanism. What you see, the red bar, these are the mean plus minus 1 standard deviation. In the red bar is when you have to, basically play the school choice game and the lottery game and the information acquisition all together in the first round. So that's the costly to free. And the blue ones are the free to costly. So you separate the understanding of the mechanism with trying to figure out how much to pay for the information. So the bottom line of the empirical result is all comparative statics would go through, but the levels are off. And so the empirical exercise is basically to figure out why the levels are off compared to the theoretical prediction. So what you see here, the dotted lines are the theoretical predictions under risk neutrality. And we also look at the risk-averse situation. It turns out it's the same, essentially the same phenomena. So yes, so people's willingness to pay under IA is significantly higher under DA. But here you already see basically two features. One is that they're closer to the theoretical prediction if they play this in the second 10 rounds compared to the first 10 rounds. So there is some learning, and it seems that the cognitive load matters, okay? And you see very similar things with willingness to pay for others' values. Again, the comparative statics hold, but the levels are off. So after we got our data, we thought, oh, how interesting, excess willingness to pay for information. But if you look at the prior experiments on information acquisition in voting or in the auction context, it's actually in every paper, okay? And people have different ways to rationalize it, such as regret avoidance. And what we do, which is taking advantage of the battery of measurements, is to decompose the willingness to pay. So this is the Tobit regression for the subject average willingness to pay. And the reason for using Tobit is because 18% of our observations hit the boundaries. And what you see here is we pick up several factors that seems to predict either higher or lower willingness to pay. One is the proportion of times that you play a dominated strategy with free information. So that only applies for the DA, okay? So in our sample overall, it's actually not a huge amount. I realized that we discussed the whether people recognize dominant strategies and so on. So it's 5% in the entire sample. But if you're more likely to play dominated strategies, you have a significantly higher willingness to pay. Curiosity, which is what we use to measure people's willingness to pay for non-instrumental information, is also significant in predicting your willingness to pay, as well as what we used to call cognitive load, and sometimes people have issues about whether it actually represents cognitive load. So if you play the costly to free condition, so we give you everything as soon as you start playing the game, you have higher willingness to pay. And risk aversion, it turns out that once you control for demographics, is no longer a significant predictor, but it goes in the direction that theory predicts. Okay. So once we identify these factors, we're going to decompose the willingness to pay. So we have a random effects Pano-Tobit regression, which I'm not going to show you. It's in the paper that's posted on our website. So basically, in addition to the factors that we picked up from the regression that we presented before, we also picked up learning and conformity. So conformity, learning is straightforward, which is the willingness to pay decreases over time as people accumulate experience with information acquisition. The conformity piece basically says that people's willingness to pay increases with their guess of the average willingness to pay of the other two participants. So this is puzzling because in this setting, if you expect the others to pay more, you should free ride on their information acquisition. And what we observe is just the opposite. So this is, we call it conformity. So what you see here is the decomposition of the subject willingness to pay for information. The top line is the data in different treatments. And the bottom line here is the benchmark, which is the theoretical prediction. So the, yeah.
I guess it's a more general question. But so here you find that there's sort of extra willingness to pay for information. How do you square this with the practical evidence that, like, you know, in like when we choose like health insurance plans or annuity plans or even like school choice, we seem not to have the information that we need to make those important choices? Like Hogsby's work, for example, that you've highlighted at the beginning, that, you know, low-income students don't know that they can access like.
Okay. Yeah. So we also find these people with zero willingness to pay, which is coming up. So right now we're just talking about the averages, and then we're going to talk about the heterogeneity, about people who are always submitting zero. So in reality, you know, in the Hogsby and Turner's work, you know, is it because they're not willing to acquire information, or it's a belief that it's not there? You know, it's not clear. So the intervention where you send financial aid information to students has quite strong effect, which means that once you send the information, and it's in a very digestible form. So I'm thinking of Sue Danarski's field experiment at the University of Michigan's admissions office. You know, it's a postcard which says that, you know, if she targeted the high achieving students in low SES neighborhoods, public schools of low SES neighborhoods. And it shows that the likelihood that they apply for Michigan and also the yield rate are significantly higher than the control condition. So that's more of an information provision piece, which we're going to, which we'll also look at for the welfare analysis. So that's not students going out and acquire information on their own. It's given to them. It's a postcard that landed in their mailbox. Right.
So I guess the way to rationalize the fact that students don't go and actually acquire this information is that the cost of acquiring this information is somehow too high?
It could be, yeah, or they don't know where to acquire the information. Okay, so for the decomposition, for instance, what if, how do we model learning? We look at their last period behavior and essentially replace their first 9 periods with their 10th period behavior, the strategy, and figure out how much learning explains the willingness to pay. And after the decomposition exercise, we show that conformity explains about between a half to nearly a quarter of the willingness to pay.
It's my computer, so
Okay.
it's not gonna.
Okay, thank you.
That's my finger.
And also curiosity explains about a quarter, roughly, of the willingness to pay for information. So that's the first part, which is on average, people have excess willingness to pay for information. And we also look at the case where we also have about 15% of our subjects who always submit 0, right? So these are people who are not willing to acquire information. In this case, for the DA other value, it is the optimal strategy, whereas for the other treatments, it's not. So the regression analysis that looks at who have demand for information, who have 0 demand for information, identifies basically curiosity. People who are less curious are more likely to have 0 demand. The other one we don't really know how to explain, which is our Asian subjects are more likely to submit 0 demand for information. So one question is, for people who have 0 demand for information, is it because they're not good at using this information? So if they don't know how to use the information, then it's a rational response not to pay for it. And so the experiment design allows us to actually look at this conjecture, which is we have the free information condition. So what you see here, the white bar is the information provision case, which is the information is given to you. The postcard lands in your mailbox. And so in this case, you have people who have 0 demand and those who have this is positive demand and this is 0 demand. It turns out that we can reject the hypotheses that 0 demand participants they're not as good as using this information. It turns out that they are as good and in some cases better at using the free information compared to others. And whereas the second hypothesis is that costly information acquisition hurt these people while benefiting others who have the opportunity to obtain more information, so we cannot reject this hypothesis. So this is a relatively small sample, we see the directional prediction, which is they are hurt by not acquiring information. Okay. There's also some welfare analysis. We also did some welfare analysis on the information provision and acquisition result. I'm going to talk about the 3 policy analysis. One is, you can acquire information if you like. So this is very much in the experimental setting. So this is the laissez-faire design. The other one, the counterfactual, is we provide free information on your own values and costly information on others' values. And the second counterfactual is free information provision on both your own and others' values. The bottom line of this is that the counterfactual 2 is the best, which is free information on your own values is welfare improving, which makes matching more efficient. So that's understandable. So why providing information on others' values? This is primarily because people, even under DA, over-require information on others' values, even when theoretically they should not. So that avoids wasteful gaming. So let me wrap up and talk about some of the real-world examples of information provision. So what we have found in this very controlled environment is that the incentive for information acquisition varies across mechanisms. So we also differentiate between information acquisition on your own preferences versus others' preferences, and what they're used for, for preference formation versus gaming. And we showed from our experiment that all the comparative statics results in theory are supported in data, but the levels are off. And so our decomposition exercise allows us to identify the empirical, the behavioral factors that contributes to the over-acquisition. The welfare analysis indicate that free information on people's own values are welfare improving. That's true in both theory and the experiment. Whereas free information on others' values, theoretically there should be no use under DA because it's strategy proof. In the experiment, it's actually welfare improving under both mechanisms. So what are the decomposition exercise says that the excess willingness to pay can be decomposed, primarily be accounted for by curiosity, which is the willingness to pay for non-instrumental information, and conformity. I expect others to pay, therefore to invest, to acquire information, therefore I also acquire information. So what does information provision do? They can take several forms in terms of policy implications. One is to make information that's already there more accessible. So Hastings and Weinstein's experiment is a good example, where you have several hundred pages of brochures on schools which are alphabetically ranked. All the information is there, but it's costly to digest. You can, if you reduce it to 3 pages of relevant information, it actually changes people's choices. The other part is there are some ethnographic studies of New York City public schools, which, these are studies where the researcher would go into the schools and interview the students and counselors. Some of the guidance counselors actually advise to the students that you don't need to rank all 12 schools. You can just, maybe rank 5, and which is not a good advice because New York City uses a capped form of DA, and at the end of each year there are a fair number of students who are unmatched. So training guidance counselors and teachers can be a much more effective way of providing information. On the mechanisms side, there have been some evidence that there are mechanisms or implementations of mechanisms that provide information on other people's choices. So one example is the Wake County, North Carolina mechanism. They use the Boston immediate acceptance mechanism, but allows parents, so they publish the people who rank each school as their first choice, and allows the parents and students to revise based on that information. So that's one way to provide information on others' preferences. And this example is from Fujito Kojima. So if you look at the Japan residency matching program, it has a very similar set of information feedback. So they list the number of students who list each hospital program as their first choices, and you have a period of time to revise. That's also true for the University of Tokyo. The most radical form is the college admissions mechanism in Inner Mongolia, which is a fully dynamic DA in the sense that students can continuously revise their preferences within a short period of time, where you know the other students who apply for the same schools and as well as their test scores. My doctoral student, Yin Zhiliang, has a working paper with Bingling Gong, which provides a theoretical analysis as well as experimental evaluation of the Inner Mongolia mechanism. So these are some of the empirical practice where others' information or strategies are provided. So in this case, for example, they showed that it outperforms the static immediate acceptance and is comparable to the deferred acceptance. So this is all I have. Thank you.
You have time for one or two questions, if there are any. Okay, well, you can also catch Yan right after in the reception. Why don't we thank Yan again?